Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is sell up to 2. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. There are n days and the selling price of a watch on the ith day is AI. Now initially we have 0 watches. Starting from the first day, this is what will happen. First we will acquire one free watch on each day. Then on each day we can choose to sell up to 2 watches that we own for AI coins each. We need to find out what is the maximum profit that we can obtain by selling the items. For the input format, we have t test cases, and for each test case, we will have two lines. The first line contains the integer n, and the second line contains n-spaced integers, those being a1, a2 till an. As for the output, we have to output on a new line the maximum profit that we can obtain by selling the watches. As for the constraints, number of test cases and length of the array will go from 1 to 100, and the selling price of watch or the elements in our array A can go from 1 to 10 raised to 7. Let's see some sample inputs. So for the first sample input, our array has 3 elements. In short, there are 3 days. The selling price of watches on each day is 1, 2, and 3. So let's say on the very first day, we have initially we have 0 watches, right? Let's say this is watches. Initially we have 0 watches. On day 1, we get 1 watch. Now we can choose to sell it or we can choose to keep it with us. So since this is a very low cost, low selling price, and we know that later we have 2 and 3 with us, we will not sell our watch. Then we go to day 2. Here we have 2 watches. Now we can either choose no watches here, we can choose one watch, or we can sell both the watches. But let's say we choose to sell both the watches here. In that case, this will cost or this will get us a profit of 4. But now when we reach to the third day, we only have a single watch. Here, the selling price is 3. Now if we sell it, it will sell for 3. So the total profit will be 7. But we could have sold an additional watch here, right? So let's say what would happen if we did not sell both the watches on day 2. So again, on day 1, we acquire one watch, but we sell 0. On day 2, we acquire one more watch, but we choose to only sell one. Since we sold one, it will give us a profit of 2. Then on day 3, we acquire one more watch. So now in total, we have 2 watch on the third day. So we choose to sell both of them and we get 6 as the profit. So the total profit is 8. We cannot sell 3 watches on third day because we can sell at maximum 2 watches. Therefore, the highest profit that we can obtain here is 8. Let's see how we can approach the solution. So if you think about it, in our array A, we have one additional or one free watch for each day. So if we wanted and we are not greedy, we can just sell each watch on the same day and get a profit. That is the least that we can do. But since we want to maximize our profit, what would we want to do? We would want to not sell our watches on the day where the selling price is low, and we would want to sell them when the price is high. Let's take a sample example here. So let's take the last example, that is 2735. 2, 7, 3, and 5. Let's say we come to day first. We have a watch, we sell it, right? Profit becomes 2. We come to day 2 and we again get a free watch and we try to sell it. But we notice that this price is higher from what we had already sold. So what we would do, we would simply choose not to sell on day 2, right? And choose both the watches here. So on day 1, the watch that we sold, we will do that, we will not sell it. We will choose to revoke this and we will say that we want to sell both the watches on day 2. Now if we do this, the profit becomes 14. On day 1, the profit becomes 0. Similarly, again, on day 3, we will get one watch and we'll sell it. This will give us a profit of 3. Then on day 4, again, we'll get a one free watch and we'll obviously sell it. But we'll see that the selling price previously is less than what we have here. So again, what we'll do, we'll revoke this, right? And choose to sell both the watches on the fourth day. This will give us a profit of 10, total being 24. And as you can see, that is the maximum here. So although we don't have any operation that says that we can revoke it, but we can simulate it in a similar fashion. Because if you finally see what we have done here is, on day 1 we chose to sell nothing. So with this, on day 2 we have 2 watches. Again on day 3 we choose to sell nothing, and again on day 4 we have 2 watches. The key here is that whenever we are trying to sell more than one watch, we can only revoke from the previous what we have already sold. So to approach the solution, what we'll do is we can have a set with us, or let's say map or anything, something that will keep track of the lowest price that we have sold at. So with this, let's say we have a priority queue, right? With the lowest element first. So with this, what we'll do is every day, whatever selling price is there, we'll sell our watch at that. So in this case, the first day was 2, we sold it, right? Then on the second day, we have 7, we again sold it. But whenever we are selling our watch, what we'll do is we'll check if in this set, what is the minimum price that exists. If the minimum price is less than what we are selling for today, what we'll do is we'll simply revoke it and choose to sell what we have today again. So in this case, we sold the watch with the cost of 2. We check what is the minimum, it's still 2. So we do nothing. Then we sold the watch for 7. We check that the minimum is 2. So we'll revoke it and choose to sell 7. Then on the third day, right, we have the cost of selling as 3. Again, we will sell it because the minimum is 3 itself. But on the fourth day, when we choose to sell the fifth, right, the watch for the cost of 5, we know that the minimum here is 3. So we'll revoke it and choose to sell 5 instead. And with this, we get the total cost as 24. And this is the maximum profit that we can make. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. And solve will take the input of our array. Then we initialize a map. With this map, we can get what is the minimum selling price that we have with it. And for each selling price, we will also have a count of how many times we have sold it. So when we get the first element, we add it into our map. Now once this is added, we find out what is the smallest element in our map. We do this with m.begin and we get the first to find out the amount. Now if the smallest is less than what we have sold, then what we'll do is we'll remove the smallest from our map and push in the current element. We'll keep on doing this, and at the end, in our map, only the elements will remain that gives us the maximum profit. So we sum them up and print it. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve and we take the input of our array. But in Python solution, what we do is instead of using a dictionary or a map, we use a heap. Because if you remember, we only want to find out at any point of time what is the minimum number that we have stored here, or the minimum amount that we have sold a watch for. So the first, whenever we encounter an element, our natural reaction is that we'll first put it into our list. Once it is there, we find out what is the minimum element present here. If that is less than for what we have sold today, we'll simply pop out the minimum one and push the today's value again. In turn, we are choosing to sell 2 watches on this day. We will do this for all the elements, and at the end, it will remain only the elements that give us the maximum profit. So we pop all of them out and sum them up. And as you can see, I have AC in Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.